Hi everyone! Next we are going to present our research entitled Design and Construction of an Anthropomorphic Robotic Head with Gestural Projection. Let's talk about the following content. Background, objectives, scientific review, mechatronic design, tests and results, conclusions. Justification and importance. To define the concept of a robotic head, it is necessary to start from the definition of a social robot. A social robot is one that achieves communication with the human beings, understands and even relates to people in a personal way. It also has the ability to understand humans and in turn make themselves understood by them. For this reason, social robots have become a very broad field of study. The growing need for robots that can be introduced in uncontrolled environments and that help with daily tasks such as education, entertainment, social assistance, and company. The definition of a social robot head is a social robot whose objective is to simulate or pretend expressions of the human face to facilitate human-robot interaction throughout the use of different technologies such as mechanical actuators, avatars on screens, or projections of light to generate a better predisposition of user towards the robot, allowing it to perform better in the task to which it has been assigned. A very important aspect is the anthropomorphism of the head. This has been achieved with the size at present in electrical devices have chosen to reduce their size to the point of achieving greater portability but without leaving performance aside. This has allowed the head to have a size very similar to that of a middle-aged human, thus avoiding the use of large projectors that greatly impaired the aesthetic and anthropomorphy of previous developments. Then, basing ourselves on social robotic and in order to have an acceptable anthropomorphism, our concept is Kyle.
Objectives. The principal objectives is design and build an anthropomorphic robotic head with gestural projections. The specific objectives are design, build, and obtain the mechanisms and inverse kinematics of the robotic head. Development and implement a gestural projection system to the robotic head. Generate and integrate interaction modules such as TTS, FTC into the robotic head. Create a graphical interface to facilitate the operation of the prototype. Integrate a sensor system to the robotic head for the simulation of the sense of sight and hearing. Robotic heads. The advances the technology in different prototypes that both mechatronic and projection head are present. The beginning of the road projection is born in the projection image in the haunted house of Walt Disney, where the moving image of a human form was projected on a face-shaped screen, resulting in a 3D projection. However, the projected material was only based on a film. It was not yet implemented in robotic applications. Kismet is a robotic head that appeared in 2002, built and made by Dr. Christian Bresser. The robot can imitate certain human history and also move the eyebrow and mood. Later, the robot named Grace, built for RWI, has an expression fed on a panoramic platform. Grace can speak with a high quality, speak sentences and understand and respond with her microphone and speech recognition software. During 2004, there are some prototypes of an iCat. It was developed by Philips Company, an emotional intelligent user interface robot. Another type of construction is Android. A first approach is the Albert Hugo robot. It was a robot humanoid. It was a robot humanoid created by Cash. Its main characteristic is to use synthetic skin in order to alternate one more real resemble. Other academics create Cheetah Club, a project retro robot that combines a physical and virtual environment. Later the Android Zero and Gemui made their appearance, also within the different investigation of real projection the sharing laws. Are Hashimoto with the robot Kamin FE81 that have a facial expression function and use a curved surface script in addition. They are light-head and mass both. In the latter research of real projection, Socibot, implemented in 2014, in fact to be a contact and social robot designed to interact between human or robot with the ability to detect face, feature, emotion, spin, and gesture. In 2018, the Fulton system was developed in Tengai that uses projection technology to transfer affairs to a mobile device within the shape of the head, has visual tracking in real time. A camera tracks wherever in communication confuse her, allowing the head with 3D grade of freedom. They move naturally similar to a person in order to maintain eye contact. And finally, Kylie is an anthropomorphic head with gestural projection, consisting the three main parts are the mobility mechanism, the project system, and the robot housing. It is similar to Furhan Tengai, but the difference is the reduction in the cost.
Mechatronic design. Next, subsystem. The function are support for actuators and projection system and generate heat movement. Other gesture projection subsystem. The function show face and expression. And in interaction subsystem, the functions are face recognition and tracking, chatbot, HMI design, and this communication subsystem, the function is communication between subsystems. Mathematical modeling is the mobility mechanism is designed in order to simulate the movement of the neck that a person has, that is, to allow flexion, extension, and rotation movements, and to support the rear projection system and carcass. Taking this consideration into account and parallel R is R configuration mechanism was designed as shown in the figure. 1. Upper platform, which allows the attachment of the outer part of the head and server as a support for the projector and fish edge length. 2. Lower platform serves as the base for the motors. 3. Universal joint. The universal joint that allows the upper platform to rotate into degrees of freedom. 4. Tie bars. The connecting rods are two parallel axes that are attached to the upper and lower platform by means of a swivel system and allow the pitch and roll movement. And finally, lower base. The lower base, which is the support of the robot and contains the motor that allows the rotational movement in the missing axis of the tree, which is yaw.
Mathematical model. The inverse kinetic of the robot was carried out by means of the graphic method, using rotation matrix a vector as shown in the figure. The method allows generate a polygon of vectors, which once solved showing the following result for the fins 2 degree of rotation. That is to say, theta 2 and theta 1. In the graph, you can see the points that were taken into account for the generation of the vector. In the points, the lower platform is observed taking was point 0.0, the start of the base in the center of the bar. In the points B, the upper platform is observed and the value of the points can be observed. If the instance will contribute to the value obtained in the equation representing A, B, and C and D. It can be sin W results are a combination of sine and cosines due to the rotation matrix used. It also depends on the angles of inclination of the universal joint as well as the ends of the committing bars. For the angle theta 3, the design of the system allows the calculation to be suppressed since it takes the value directly from the servo motor that controls it. The inverse kinetics allow obtain the equation of movement in order to achieve the best control of the mechanics, in order to avoid sudden or jerking movements that could cause a negative reaction from the user. Of the contrary, more harmony and continuous movement raise the level of acceptance and allow to meet the objective of anthropomorphism. Gestural projection system. One of the most important systems of the robot is the gestural projection, shown in the figure. The system consists in 4 parts, each of which on specific tasks that are described below. The carcass is the standard part. Its main task is to contain and to protect the internal parts from external action that may damage them in any way. The project is a chart of generation designed to present a receive the desired image in the software that is sent by an HDMI connection from a computer. The main task of the first F lens is to generate concavity to the image, allowing it to fit to the projection mask and to generate a higher level of acceptance to people. And finally, the projection mask allows the image to be shown to people generated by a thermoforming process in open acrylic material.
Animation gesture. The animation were created in Software Blender, a program for modeling, rendering, animation, and creation of three-dimensional graphics. It also allows the handling of animation through programming code in Python language. First, it's necessary to talk about certain Blender concepts such as shape case. The shape case are tools used for the deformation of objects such as messages, curves, and surfaces. They are commonly used in the facial animation. In the figure, you can see the creation process of the left the original versions. In the center, the selection of surface, and on the right the final position. Frame. It is a basic element for animation of elements in Blender. It can be analogously considered as a real skeleton, and it has several bones. In figure, you can see the frames for the generation of gesture. Bones. These are basic elements that are linked to the frames and allow to control to movement depending on the shape K to which they are associated with. In the figure, you can see the bones used for the movements of gesture. Keeping the mentioned concept clear, a total of 13 shapes K were defined each with the respective bones and connected to a general frames for movement. After defining the shape Ks, we proceed to define 13 units of action, which are defined as action performed by the face in order to transfer information through facial expression. You can see in the table, it shows a description of the action units, shape, case, and movements. The anthropomorphic head has several gestures that are born from the combination of different action units. Among the most important, we can find happiness, anger, sadness, and surprise, and are shown in the table.
The robot was fully programmed in ROS environment. It has a total of 18 nodes which are separated in order to fulfill a specific function. The most important nodes are that allow the entry of data from the world that are located in the left part enclosed in blue. The nodes in the center located in the red part are the nodes that process the information and transfer it into information to send abroad. Among the most important nodes can find artificial vision, Rosaria. On the right side, there are the connection bridges of the root system to the outside world. Considering the most important nodes are a bridge with Blender and the Arduino microcontroller for controlling the servo motor, and allow recurring movement as can see in the figure. The node are structured in such a way that they fulfill the specific tasks below. Each node is described with the respective steps that is fulfilled and the function that need convenient generate. Natural language. The nodes are described below are used from the person Kylie dialogue. Listening is a node that allows Kylie to interpret what a person says and translate it into text. It is done using the Google Speech to Text package. Dialogflow is a natural language platform used to implement conversational interface. Through the question answer system which allows Kylie to create his answers to everyday question and to add more questions and answers quickly and easily. Gesture is a combination of action units which allows to show eight and more movements for presentation of the face. Gesture. The generation of gesture is carried out through the following nodes. Gestures interpret serial data that are set by the bridge between ROS and Blender, and later to process and to transform them into movements that will be present on Kylie face. ROS bridge. It is a bridge between ROS and Blender that is generated through the client server configuration and Python library in order to allow communication for sending data between Blender and ROS. Bisemas for the transformation that takes in movements for is later sending through the node. Blender is shared of generation model on the face. It uses the program of function that will be explained later. Movement. The several of nodes below generate the carry movement dependiendo of the model chosen and the functionality is fulfilling. Road job. It is a node that allows the interpretation of the action carried out by the user in the command control, joystick, to transform them later into movements that are sent to the inverse kinematic in the form of arrangement of triangles for each of the robot freedom degree. Artificial vision. It is a node that allows the detection of people fetch and takes the nose of a person as a reference to set coordinates to the tracking node. Tracking allows the transformation of the coordinates to angles that can be interpreted by the inverse kinematics of the robot. Inverse kinematics calculates from the angle sent by the tracking node the value that each of the actual should turn using equation 1 and 6 and set it to the node found on the Arduino control board. Road serial. It is a road-on node that allows communication with Arduino card through the serial port and by sending an array of three data that are their value to rotate by each of the motor. Arduino. It is the child of moving the three motors, each one at the indicated angle by the inverse kinematics node.
Tests and results. Mechanics test. The 3 degrees of freedom mechanics in order to check the validity of its inverse cinematic system was designed that consisted of a gyroscope that was coupled to the upper platform and entered rotation values in roll, pitch, and yaw that were processed by inverse kinematic and sent to the rotation of the motors, and at the end check in the motor reached the same value that was designated in the test. The results obtained are shown in the figures. Starting position 70 degrees, 75 degrees, and 90 degrees. Motor angles 47 degrees, 98 degrees, and 90 degrees. Motor angles 77 degrees, 84 degrees, and 90 degrees. Motor angles 70 degrees, 75 degrees, and 90 degrees. Motor angles 78 degrees, 56 degrees, and 75 degrees. As can be seen in the angle column obtained by the gyroscopy sensor, the error presented by the mechanism is a low error and is mainly due to range of the servo motors and the precision of the signal sent by the Arduino microcontroller. Animation test. The animation tests were done in order to calibrate projector and lens position, and at the same time to find the ideal values for the filters of the Blender software in order to achieve the best presentation in the figures. The gesture can be seen of the right: happiness, anger, sadness, surprise. As can be seen in the face of the left, these are already implemented in the robot. The lens and fisheye set give the image uncertain concavity and the way in which the projections mask was created allows a complete passage of light, allowing the face to be shown in a natural way and the emotion to be easily recognized.
Usability test. The usability of the robot was evaluated by the SUS System Usability Scan method, which is a tool that allows measure the usability of a widget device or application. The results obtained are reliable. The SUS survey was conducted on 22 people who range in age from the 22 and 26 years. Of the people choose home experience in handling technology as well as some approach to social robot, but it was the first time they have interaction with the robotic head Kylie. Before starting the test, everyone received an explanation of the basic functionality of Kylie. Once the introduction form was finished, each particular button a questionnaire contained the aforementioned question and to which the score answer and a sub-scale. Effective system, efficiency, easy to use. The questions were taken from the original text of the usability.gov page and attached to the place that was chosen, the Mechatronics Laboratory of the University of the Forces Armed SP. After the 22 servers that were answered anonymously, the interpretation was carried out using the aforementioned scale, given the result shown below in the table. The result of the survey of 82.5 of 100 that indicate that its acceptability is excellent. Also, it is necessary to clarify that since it is a prototype, it still has several aspects in which it can be improved, placing emphasis especially on aspects such as a user-friendliness that are not related of knowledge about technology, as well as expanding the range of people selected from children to other adults.
The main theme of the document is the design and construction of Kyle an anthropomorphic head with gestural projection has a parallel mechanism of 3 degrees of freedom that allows it to simulate the movement of a human neck. A gesture projection system and sensor for emulation of the sense of sight and hearing. One of the most important systems is the gesture projection system, which was developed in Blender and allows the robot of a more fluid interaction with people as well as a question and answer system that was implemented through dialog flow through the use of libraries of Google Assistant. Kyle has two main advantages over commercial robots that have similar functions. The first, flexibility present in the generation of gesture, allowing the number of gestures to be increased and decreased. Another aspect where Kyle's flexibility comes into play is the application for which it is intended. Being a prototype robot was designed in such a way that it can be used for various purposes. This is thanks to the use of dialog flow, which allows generation questions and answers for any topic and of great complexity. The second advantage, it is low cost. It is a system under development, but compared to current systems on the market, the cost is extremely low, largely thanks to the large amount of free software that was used. Kyle's usability as a whole was tested by 22 people who rate the robot through the SUS scale, obtaining a result of 82.5 that allows us to conclude that the robot has acceptability usability that it complies with the parameters of effectiveness, efficiency, and case of use. Thank you very much. To continue, we show the video of operation demonstration. ¿Cómo estás? Un dato curioso. Sí.